All right, so we're in AP Calculus. Today's date is Thursday, December 12th, 2019. Lesson 6-3, which means if I'm looking at my unit guide, we have, this is the last lesson, obviously. We have self-check tomorrow, self-check on Monday, and then we have, wait, how does that work out? That means that the pretest and fix-up and test is on, oh wait, we have a whole nother, no, this is the last week. What's happening here? Am I off? I thought that we had our test on the day of finals.
Oh, we'll probably have Monday.
I think what we're going to have to do then is the pretest, fix-up, and the test then all on the day of the finals.
This is dumb.
That's a lot. I did not want it to happen that way, but that's the way that it turned out. Why did
we take-home pretest?
I think let's do a take-home pretest, yeah. That'll save us.
For what day? Monday?
We'll do a take-home pretest on Monday, yeah. Which means you have to watch the video and do the fix-up all on your own. And then you'll come here on finals day, you'll take the test, finish the test, and then do a lesson. All right.
Why can't we do fix-up and then test on Sunday?
What are we doing tomorrow?
Why can't we do fix-up and then test on?
Why can't we just do the take-home pre-test and then on test the final day we do the fix-up and then we do the test?
Oh, that's a good idea too.
I like that idea because it's not just testing the beginning of the lesson and we don't learn stuff.
So I'm assuming then you're still watching the video for the pre-test and then you're just ready to only do the fix-up the day of the actual test, right? Or do you want to actually review the...
No, I think we should do the fix-up before.
Okay, yeah, let's do that. I like that plan. So again, just to make sure everyone's on the same page, and I'm talking to you too, Gio. We're doing like our normal stuff, self-checks and stuff, but then on Monday we're going to do self-check 6.3 and 6.4, and then I'm going to give you a pre-test for the homework, which I expect you to not only take, but to grade yourself, and then to look at the answers, and then coming on, when is our final? Is it Wednesday? I think it's Wednesday. Wednesday afternoon. On Wednesday afternoon, you're going to come to class already knowing all the answers to the pretest, only focusing on the fix-up for the first part, and then we'll take the test, and then we'll do a lesson. All right.
We might already be dead when we come into your class because we have history.
Okay. Well, I'll take what I'm given. So let's do lesson 6-3. So this is kind of that notorious one where you don't really need to do this. Like John Wynn's curriculum, he doesn't have a 6-3. He doesn't really teach us. I figured I'm putting it in because we have Claire who probably wants to get to do that final step. And maybe you're curious, you're like, well, what is the actual answer? And I think there's, like last year I taught it in a hard way, the year before that was even harder. I think I might be able to boil it down so it's nice and easy this year, where everyone's like, yeah, that's a point. I can spend like 5 minutes doing that. Maybe you're in that boat, maybe you're not. It is a lot of minutes, you're correct. All right, so we're doing step 4 today. Yesterday, we were just doing all the way through step 3. Again, list the first 3 steps, and then obviously step 4 is there. Step 1.
Separate.
Step 2.
Integrate. Evaluate.
Evaluate.
I got it.
And then step 4,
I copied Sego.
isolate. Let's do it all again. 1.
Separate.
1.
Separate.
2.
Integrate.
3.
Evaluate.
Good. And then Arrow always says plug in, which I mean you're correct. It's just last year you always said plug in.
Anyway, back to the 6-3.
Back to our lesson. Isolate means getting the y by itself. Get y by itself. Yeah, I wish we had like a raised desk. You might be able to, maybe you could like prop it up on this, and then put a whiteboard on top of this. That was like a standing desk.
You just put it right on top of it.
She doesn't need that. Oh, I have a bigger whiteboard. Right. Mr. Warner took it and didn't get back.
Of course you did. Who took it?
Mr. Warner. Ooh, what about this thing? Is this thing longer?
I think this is fine, but
All right. Many distractions. So whenever you isolate, you essentially need to find C using the initial condition. So we haven't done that before, but it seems pretty straightforward. Find C. And that's going to be using the initial conditions. Oops. Using initial conditions. And when I say initial conditions, what I really mean by that is this thing. When f of 1 is equal to 2. We've seen that before. We've evaluated. We've plugged those in. But now we actually have to find that C after we plug in. And I should mention that once you find C, then you're going to plug in that C. plug C into the original equation, because you're kind of like, you found the original equation but C, you do a bunch of work to find C and then go ahead and plug it back into it. Original equation. And then make sure, like, you might have already gotten y by itself, but definitely verify that y is by itself. Y is isolated. Sometimes you can find C when y is not isolated, and it's a little bit easier, so that's why I'm putting it in there, just to really verify that. And then there's kind of a final check that is not in last year's notes that I'm adding this year, which is this, and I'll do it in red because I hope that it works out. You have to verify. Verify initial conditions. I believe that if you just verify the initial conditions, it kind of avoids doing a lot of harder, very technically correct math. There's kind of I think, a shortcut. I've tried it in 4 different AP problems, and it's worked in every single one of those 4, so I think it might be the shortcut that we're looking for. Again, I'll be trying it more this year. We'll see if it works. You're kind of guinea pigs in that aspect. You have always been guinea pigs in pre-calculus. This is the first time in AP calculus that you're now.
Me in general since freshman year.
That's true. Yeah, I'm sorry, but your sacrifice is going to help generations of students to come. So I'm going to find the particular solution, and this is kind of the key word that is really hard, like a month down the road when you're here in like February, 2 months down the road, and you see the word particular solution. That is the key thing that says, hey, you need to do separate, integrate, evaluate, isolate. Yes, isolate. Woo! I was making sure I got it there. That's the key thing. Like, you guys probably will remember those 4 steps 2 months from now, but you won't know when to apply them. So knowing when to apply them, if you ever see the word particular solution, I don't even care what context it's in. If it says particular solution, you are going to be doing these 4 steps. Please underline particular solution. That is your keyword saying, hey, you're going to be doing those 4 steps. What are those 4 steps again?
Separate, integrate, evaluate, isolate.
All right, so I'm going to, from now on, for the rest of the day at least, Stego, you cannot do those 4 because you obviously know them. You have them down. These 2 I'm worried about now. So between Aaron and Claire, step 1.
Separate.
Oh gosh. Step 2, both of you. I know. It's okay.
Evaluate, isolate.
Okay. We're going to get better at that. Good job, Stego.
Separate, integrate. I don't know.
I want to get off task and ask Claire why she's tired, but I'll ask her after the lesson. So let's do step 1. Separate. Separate, right? Separate.
Yes.
Spelling is not my forte. All right, so I have my fraction on the left, but I don't have a fraction on the right, so I need to make that a fraction. And then I do what? Cross multiply. So I'm going to do my dy first. So I have 1 dy, or I can just leave it as dy if I'm not being pedantic about it. We love that word in math, right? Then I cross multiply the other way.
Like on a daily basis.
The word pedantic?
Yes.
It was a big joke last year.
I'm pretty sure there's like some mathematician that's going to eventually watch these videos. It's like, you're not being pedantic, you're just being precise, which is a value that all mathematicians should have. And there's an argument to be made there as well.
So you can say you're not being pedantic when you say you're
I should just say, I'm being precise, which is a value that you should all prize.
But I didn't learn the word pedantic last year, so that's why it's...
What am I going to do to finally end my separation? Right now they're not separated. I have x's and y's all grossly mixed up.
Divide by x.
Get
No,
the
divide by y.
and x's on different sides.
Divide by y to the power of 3, divide both sides by y to the power of 3. So my new equation after I separate everything, and I should write down here in a new color. My y kind of swooped down here too far, but it's 1 divided by y to the power of 3 dy is equal to x dx.
You just got really quiet.
Did I?
Yeah.
Now I'm going to whisper, so you guys have to pay attention a lot more closely. Is that a strategy that I shouldn't be employing? Random feedback that the psychologist came and told me I am the loudest teacher, and it might be a good strategy for me to whisper more often.
Is this psychologist?
Yep.
No, because it means you're eager. The person more important.
And make sure that you're paying attention more. If you guys aren't talking, then Step number 2
There you go.
is to do what? Integrate. Yeah, Stego, you got it down, and I appreciate you helping your peers, but make sure that they have it down as well.
I don't know
All right, how do I integrate?
The antiderivative of
Antiderivative.
y
Write
to
down the
negative
integral.
3
I don't do 1 over y to the power of 3. You said it correctly. I do y to the power of...
y to the negative 3.
There it is, negative 3.
Y is equal to the antiderivative
I don't know
of
what
x
just
dx.
happened, but okay.
Basically, take this same line, slap on these integral symbols, and make sure I don't have fractions or radicals. Get rid of those radicals. Just like... I'm going to make a historical reference, but I'm probably going to be wrong, and Mr. Godoy's going to be like, Mr. Sandell is teaching you incorrect things before the AP or the test.
Roy says all the time that he can hear Mr. Sandell like cringing because he does math wrong. In that
Okay, so we're balanced in that way. Okay,
What's the historical reference?
you should be like the Bolsheviks. Like they were. Wait, what was the original thing that I was talking about? Somehow I tied in the Bolsheviks in Russia to that.
Eliminate the radicals.
Oh yeah, you have like the radical like communists that are like taking over Russia during World War I, and then people are trying to eliminate them in Germany. They're trying to stomp out the fires, even though Germany is responsible for the Bolsheviks like seizing part of Russia. They were the ones that got Lenin into. Anyway, I'm. By the way, if you haven't noticed, I'm listening to a podcast about World War I right now.
there you go.
An antiderivative of y to the power of negative 3. Yeah, so it's y to the power of negative 2. Now divide down by negative 2. Okay. I don't do the plus c on the left-hand side. I like to put it on the right-hand side. Just kind of making sure my carrots and my potatoes are not touching. X to the power of
X to the power of 2
2.
divided by 2.
Divide by 2. Okay, and then, yes, don't forget your cake. Don't forget your plus c. Thank you, thank you. And you get a point just for doing the plus c. Okay, so from here, I'm done with step 2. I'm on to step 3. And Sego, don't shout it out because I know you know it. Step number 3 is to do what?
Evaluate.
Evaluate. Perfect. Even when she's tired, she can get it. All right, evaluate. And how do I do that, Arrow?
I don't know, this is the one I was really confused on the homework, but I'm assuming you plug in the f of 1 equals 2.
Yes, somehow you're using that with this stuff.
F of 1 equals 2.
So when I say f of 1 equals 2, that means that the x coordinate is 1 and the y coordinate is 2.
Yes.
So tell me what to write in here then.
It's negative 1/4.
Careful. Oh yeah, so you're trying to multiply it all together, but you did it incorrectly. So I'm going to write it out nice and carefully. 2 to the power of negative 2, all this divided by negative 2, that was a too small 2, is equal to what's on the right-hand side arrow?
Oh, I see.
Right-hand side, you got this?
Is it 1/2?
It is indeed 1/2 plus c, yes, thank you. All right, that was evaluate. And you get a whole point just for plugging it in, even if you don't do any reducing or, what is the word I'm looking for?
Wait, so how was negative 1/4 wrong?
Negative 1/4 is wrong because it should be negative 1/8 on the left-hand side. But I'll show you that in a sec. So just by doing this on the AP test, not in my class, you get a full point just for plugging those in correctly. And then for my class, you need to actually like boil these down. You need to simplify. That's what I'm looking for. Simplify, which means don't have any negative powers. I should just have like a number. So 2 to the power of negative 2 is the same thing as 1 over 2 to the power of positive 2. I still have that negative 2 on the bottom. The right-hand side, I can't do anything. It's still 1/2 plus c. And simplifying that one more step. Claire, can you help us do that? There. Negative 1/8.
And then you subtract 1/2 from both sides, and it changes into...
You are doing step 4. Perfect. Yes, that's a beautiful segue into say, oh yeah, now we're actually going to solve for c, and that's technically step 4. Step 4 is to isolate. So now we have to figure out what is that constant of integration. So if I kind of draw an arrow from here, or draw Claire all the way from here to here, we can call it a stego or a geo as well.
Just call arrows.
No, I think it makes sense. I get so confused when I hear
The
that.
confusing thing when you have a girl named Arrow in your class.
I get perfectly confused. I mean,
We're gonna add an.
arrow.
We're gonna subtract a 1/2 on both sides. So I now have a negative 1/8 minus 1/2 on the left-hand side, and that is equal to my constant of integration, my cake, my c.
Which is Negative 5/8.
It is indeed negative 5/8. Hopefully everyone understands I have to multiply the top and bottom by 4. And that is equal to c. So we found our constant of integration. Now I need to plug it back into the original equation that had y isolated. Y was never really isolated, though. I had this equation, which is the most boiled down I ever got my original equation. So let's go ahead and plug back in the c. So I'm going to rewrite this yellow equation now in yellow. Let's keep it consistent. I have y to the power of negative 2 over negative 2 is equal to x squared over 2. Not plus c anymore. It's now minus 5/8. And then, yeah, you need to isolate the y. So let's go ahead and do that. Multiply everything by negative 2. I now get y to the negative 2 is equal to, I have negative x squared plus 5/4. I did a lot of math there and skipped a lot of steps. I wonder how many people got lost in the math wilderness. No one's still in the confused area? Ask a question, Stego.
No thanks.
Please ask me a question. I can tell your understanding by the question that you ask. That's why I always ask people to ask a question. How did I get 5/4? There's a question. You answer that.
I don't know, you answer that.
Okay, so that's the question you're asking me. Well, I got 5/4 because I multiplied this negative 5/8 by negative 2. A negative times a negative is a positive. And then the 2 and 8, I cross cancel. 8 and 2, that's 1 and 4. 5 times 1 over 4 is 5/4. Someone else ask a question. I can tell the type of understanding you have by the question that you ask.
What do you do next?
Okay, so you're ready to go. I can tell by that. Sego, do you understand where negative x squared came from? Arrow, answer it then.
Where negative x squared?
How did I get negative x squared from this?
You see how we multiplied over 2 by 2, which cancels out this 2, but there's a negative, so it goes in front of x squared.
Cool. All right. So I'm almost done. I have to isolate y. And right now I can rewrite this, right? It's a negative power. That's the same thing as 1 over y to the power of positive 2. And that's still equal to all this negative x squared plus 5/4 nonsense on the right-hand side. So I will eventually square root. But first, I don't like y being on the bottom. I don't like y being in the denominator. I can flip both sides. Assuming that you don't have any domain errors. Like, what if somehow this negative x squared was negative 5/4? If that's a possibility, then you are now dividing by 0. Well, actually, yeah, exactly. So just be careful. Is it possible for x squared to be 5/4? It might be. I don't know. It might be a domain error. Maybe this will be something that they'll take off a point. That's why I'm worried about this process. I don't know. I haven't been an AP grader. I'm assuming that we can do this. Maybe there is a reason to say, oh yeah, it's impossible to be 5/4 because et cetera, et cetera. But let's go ahead and take the reciprocal of both sides. So I now have y squared on the left-hand side. And I'm going to flip this. This is now all over 1. So 1 over negative x squared plus 5/4. And finally, as Claire said,
And do you square root the entire thing or just the bottom?
the entire thing. And then it only distributes down to that bottom.
Oh, right. Yeah.
Yeah.
There's my cool square root. And then so this is the question, right? So I now have y is equal to not the square root, but the plus or minus the square root of 1 over the square root of negative x squared plus 5/4. The question is, well, what's the answer? Is it plus or is it minus? It's not both. Ow. That's my knee.
This is why it takes so long to do this
Because it's
doing
positive on here.
Oh yeah, by the way, I should note all this stuff that we're doing now for step 4, this is all worth about 1 point.
This takes so much time.
This is the reason that John Wynn does not teach us in his curriculum. This is the why when I go over the actual AP test, unless you guys really beg me to show you step 4, I'm not going to do it. I'm just going to do steps 1 through 3. This is how you get a 5 on the AP test, doing steps 1 through 3. I'm showing you step 3, maybe wasting a day just in case you had that curiosity like, well, what is the actual answer, Mr. Sindel?
Now you plug in the x and y to see if it works to figure out.
Exactly, yeah, we're on to this step. Verify your initial conditions. So if I verify the initial conditions, my initial condition was x was 1, y was 2. So if I come down here, y was 2. By the way, I'll note that y was a positive 2, which means that our answer should therefore be a positive. So I don't even have to write it out. Like, knowing that this y was a positive 2, this obviously can't be a negative some fraction because that'll be impossible. So I can come down here and say, okay, my final answer, just scribble out that negative, or I can rewrite it all. I'm just going to scribble out the negative because I'm lazy like that.
Couldn't you just like electronically erase
Yeah, but I want to show it in my notes. Because I look at these same notes for the next year's worth of teaching. So if there's any mistakes that I caught, I'll update those and stuff. That way I'm continuously making these better and better. All right, so that was the easier one. Let's go do the harder one now.
Oh, great.
Natural log example.
Ah.
I'm scared. We haven't done natural logs in a long time. Here we go. We're doing the same 4 steps without Stego doing it. Step 1.
Isolate.
Separate.
Oh no, separate. Step 2.
Integrate.
Integrate. Oh
Evaluate,
gosh.
isolate.
There it is.
Oh, isolate.
I get the last 3 are
Yeah,
fine. The
why
first
would
one
two of
is
them start with A?
The first one is a super big problem because if you can't do the first one, then you get 0 points, right? So let's make sure we really get that first one.
I just
Don't
don't
know
know
what
the
it's
name
called.
of
Okay, that's what I don't really care if you know what it's called. I want to know that you know how to do it. So separate, separate. Ah,
it. All I
god.
think is cross multiply.
So separate. How do I do that?
Cross multiply.
Cross multiply, and it's this giant function that's going to be multiplied by x on the right hand side, but on the left hand side, or sorry, that's the right hand side. The left hand side is just this 1 dy. So I'll do that in yellow. That's 1 dy. 1 dy on the left hand side. The right hand side is going to have that, all of that, 3 minus, oh, I should do a different color here, green. 3 minus y, all of that, times cosine of x, all of that, times d of x. Done. All right, so I've cross multiplied. It was, yeah. Some of these are kind of big.
Now you divide by 3 minus y.
Yeah, so the 3 minus y because that contains the y and the y's need to be on the left hand side. So divide both sides by 3 minus y, divide both sides by 3 minus y, and I get my new equation, which has the correct separated variables, which is 1 over negative 3 minus y dy is equal to cosine of x dx. And hey, like, my mashed potatoes and my carrots are not touching each other. Everything is in the right spot. I guess it's really the peas and carrots. Have you guys ever watched Aviator? Who has OCD? There's like that famous scene where he has all of his peas perfectly arranged in like a grid of 10, and then his carrots are over here, and then like someone comes out and eats one of his peas, and he gets like really angry. That's what I'm always referring to when I say my peas and my carrots are not touching. Or if you watch Monk also has OCD. He always has to make sure his food is always separated too.
Don't you think that carrots are too sweet? They have so much sugar.
I think that sweet potatoes are very, very sweet, and carrots are naturally sweet.
Well,
A good sweetness.
Sweet potatoes.
Step number 2.
Have you seen the purple sweet potatoes? It tastes like cake. Okay, anyway, keep going.
What is step number 2, Arrow?
It is the one where you put this thing.
The integral, yeah. So
Yes, that.
integral means integrate. Yeah. So just put the integral in front of that. But I'm not just going to rewrite it because I have a fraction, an ugly, gross fraction, and I'm going to rewrite that as...
That's me, Mr. Sibel. It's a beautiful balance.
All numbers are beautiful.
He just agreed. All numbers are
That
beautiful.
doesn't mean you're right.
Oh, I was just saying, like, that would be the words that Claire would say.
You forgot the integral.
Oh, phew, I'll slap that on right there. Thank you. All right, so I've added on my integral symbols. I've got rid of my fractions and any radicals that I had. Those dirty radical Bolsheviks.
So then it's the natural log with negative 2 minus y, right?
Yes, it is. Yeah, so whenever you have a negative 1 power, that means I'm going to have a natural log. Oh, man, maybe I'm offending someone by saying that. Because communism is okay, maybe, depending on if it's implemented correctly. Natural log of absolute value of negative 3 minus y. And that'll make sure that we don't have any domain issues. And then on the right-hand side, we'll have, what's the antiderivative of cosine stego? Because I know I've been silencing you so much. This is your chance to tell me antiderivative of cosine. Obviously, it's going to be some form of sign, but is it positive or negative? Positive, yeah. Anti-change means same sign, and this was a sign of positive, so it's a positive sign. And don't forget your...
See.
C. All right, so there it is. Next, and I'm hoping to see... or I'm hoping that you guys see why this is now difficult. Not only do we have to get rid of natural log on the left-hand side, but we also have to get rid of an absolute value, which we haven't done like since Algebra 1. I don't touch on this stuff in Algebra 2, nor pre-calculus. So you have to remember all the way back in Algebra 1, how do you get rid of an absolute value on both sides? Yeah, it's a long time ago. And you weren't even in here for my class, so... hopefully you learned it somewhere in Mammoth. Maybe they're like, they didn't teach it in Algebra 1, they're going to teach it in Algebra 2, but then you came here for Algebra 2 and didn't learn it then, and you never learned it at all. That might be a possibility. Anyway, that was step number 2. We've done the integration. We are now on to step number 3, which is what, Claire?
Evaluate.
Evaluate. Plug in. Perfect. What am I plugging in, Stego?
0.
Yeah, so 0 is x or y? X, and then that's the y. Perfect. So I come down here. I'm plugging in the 1 for the y. So this is going to be the natural log, absolute value of -3 minus 1, and absolute value. And that's equal to sine of 0 plus c. And just by doing that, you get the point. But in my class, I need you to boil this down as much as possible. So this is going to be the, I'll do this in yellow to do the next step, natural log of -4. Or I can just say natural log of +4 and get rid of those absolute value symbols. And that's going to be equal to the sine of 0. What is sine of 0? Arrow.
Sine is it 0?
It is 0, yes. 0 plus c.
So then it just
we found our c, which is technically supposed to happen in step number 4, but there it is. Yeah, we've found a c. We might as well just, I'm going to pseudo say, okay, we're kind of working on step 4. This was what, Stego? Isolate.
What is the natural log of 4?
Natural log of 4. Natural log of 4 is about 1.386.
So this is one of the numbers where you just leave it as natural.
Oh yeah, very often you'll find your c to be some number that you can't actually simplify. If it's natural log of 1, then weird things have happened. It's too easy of a question. They give you a freebie. Yeah, so c, or you can say natural log of 4. That's our c. And then I go ahead and plug that back into the original equation, which we found right here. So I'm copying that down, but in the place of this c, I'm now going to say that's the natural log of 4. So come back here and say this is now the natural log of absolute value, -3 minus y. Absolute value is equal to sine of x, quantity, and then that's going to be plus natural log of 4. All right.
This is scary.
Right now, you're up to 6 points.
So we would stop it.
We would normally stop
We
right
would
here.
stop.
But no. I want to show you how to do step 4. And now I'm starting to feel guilty because you guys are cringing so much.
4 now?
You should have stopped. I mean, if you find what C is, you can get a... I don't even think you get a point.
Wait, so we have to...
I don't think they give any point for actually... Like, okay, I would say 60% of the time they'll give you a point for finding C if it's hard. This one is so easy that they won't give you a point here.
So it changes for each of the difficulty levels.
Oh yes, for sure. Yeah, your grading rubric is very dependent on the level of difficulty. Like sometimes they'll ask A, B, C type of question. Like there are 3 parts. Sometimes they'll ask a 4-part question. Sometimes a 2-part question because there are like mega problems within each time, and all for like the same content. Usually there is a pattern though. If you do like 7 AP tests, you'll be like, hey, like they always ask like 3 parts for this one. Let's do step 4. Coming up here, I want to actually isolate. How would you do that? And again, this lesson you might want to just brainwash yourself and unforget or unremember and forget. That's the right way of saying that. If you are at all confused by this lesson, and I'm apologizing a lot today, just forget it. Like you don't need it.
You multiply the natural log by e to cancel out, right?
You're really close. It's called exponentiation. And essentially what I do is I say e to the power of natural log of absolute value of -3 minus y, absolute value, is equal to e to the power of sine of x plus natural log of 4. You just exponentiate each of them. So these are now the powers. If I do that, e to the natural log, those cancel out, and I'm just, this kind of comes down, and you say, oh, absolute value of -3 minus y is equal to e to all this.
But that's the right step, right?
That is the correct step, yeah. So I'm now going to write this out and get rid of the e in natural log, and it's just going to be the absolute value of -3 minus y. Is that right? Yeah, and then absolute value is equal to, and then it's going to be e to the power of, and I'm going to do another step here. I'm not just going to write out e to the sine of x plus natural log. Technically, I can use rules of exponents and say, well, that's e to the sine of x times e to the natural log of 4.
Which would cancel out just 4.
You're seeing some cool things that are happening already. Yes, you're correct. So this is going to be e to the sine of x, and I'm not going to skip too many steps. I'm still going to write it out. You can skip a step if you like. This is times e to the natural log of 4. And then I have to do a few things. I have to get rid of the absolute value sign, so I do that by just doing a plus or minus on the right-hand side. And now on the left-hand side, I have -3 minus y is equal to plus or minus e to the sine of x times 4. And then I still am isolating, so I think I can skip a few steps here.
Is it, I think it's plus 4, because it's the sine of x plus the natural log of 4, right?
No, so yeah, you have to remember that here. Let me write the rule of exponents over here. If I say x to the a times x to the b, this is equal to x to the a plus b, and I'm going backwards with this rule, so it is definitely a multiply right there. Yeah, be careful, and there's a ton of things to do in step 4. That's why we don't do it. I hope John is not cringing at me doing this lesson right now. It is a times here 4, and then I have to go ahead and solve for y. So I'm going to do a bunch of steps all at the same time. Y is now equal to, I am adding 4, so this is going to be plus or minus e to the, I'm going to do plus or minus, or sorry, adding 3, trying to get this 3 back over. Plus or minus 4 e to the sine x, and that's going to be plus 3, and then I'm going to multiply everything by a negative. Don't have to worry about that guy because it's already a plus or minus, right? And this thing is going to be now a minus 3, so minus 3. All right, and then again, you have the same thing, a plus or a minus. Just like up here, a plus or minus. Which one do you choose? And the answer is, well, you have to plug in your initial conditions. So if I plug in 0 for x, let's see what happens. I should somehow get a positive 1, right? And that's where you have to really be careful because you don't know if this value is big or small. And you can probably tell what it is already because you're going to be like, oh, okay, plug in 0 for x. That's going to be sine of 0. So sine of 0 is what, Claire?
0.
Sine of 0 is 0, good. So that is 0. E to the power of 0 is now what, Stego? Oh,
Sorry.
you're good. E to the power of 0, anything to the power of 0 is, yeah, 1. So this is now just 4 times 1 or just 4. So it's now 4 minus 3. Should it be plus or minus 4 minus 3? It should be plus, yeah. So again, it was the positive. Sometimes it will be the negative. I did choose 2 examples that happen to both be plus. Sometimes it will be negative. So just be careful of that. And there, we've solved it. We got that final 1 point for doing all of that crazy amount of work. You not only have to remember how to get rid of absolute value, how to exponentiate sides, how to use rules of exponents, how to know like sine of 0 is 0, which I think you had to do before anyway. Yeah, you did have to do anyway. Yeah, so it's a lot of work, but there it is. I showed you guys now how to do step 4 if you want to do it, but I'm not going to ever go over this again unless you request it.
So it's not going to be on the test?
I mean, I'm going to give you this problem, and you won't be able to get full 9 out of 9 points Ben status unless you do that step 4.
Oh, because now it's not multiple choice. Now it's...
Exactly. It's free response. However much work you put in is however many points you will get. And once we do our self-check tomorrow, I will show you your first scoring guide. And you'll be like, oh, that's how it looks. And I can show you right now. I mean, we have extra time, right? What time do we get out of here? We get out of here at 11:18, so we got 10 more minutes left. Let me show you a scoring guide. What does it look like? So if I look at a scoring guide, let's do one for self-check. Something that you're not going to remember. You're not going to remember the pretest.
Wait, so we have to self-grade our pre-test?
I will grade it with you and explain why you're getting the points that you get.
You said we have to grade our own.
Oh, you're right.
take home.
I will explain it very thoroughly in the video. So here is an example that you'd have to do where it says the particular solution. Oh, it says particular solution, therefore I must be doing this separation. You do separate, then you do integrate, then you do evaluate, then isolate. And look down here. So this is where they're doing it in step C. And you say, okay, they get 1 point for just separating. They get 1 point for taking the antiderivative. Sometimes it's 2 points because it's really hard on both sides. They get 1 point for just writing the constant of integration. They get 1 point if they can use the initial condition, aka you did evaluate, you plugged them in. You don't even need to simplify, you just need to plug them in, and then, oh, they do give a point here if you can actually reduce down and solve for B. And note here, I love the notes. If they did not separate, they get 0 points.
Oh,
Whoa.
that's annoying.
They'll almost always say that in the scoring guides.
And then if you don't do the constant of integration, we're back.
Exactly, yeah. Almost all these scoring guides have those types of notes for this type of
So
problem.
you need to write C, otherwise you can't get points.
So not only should you write the C to get that free point, but you have to do C in this case. All right, so you'll see scoring guides like that in the future as well. Go away. Yeah, that concludes notes for 6-3, and this is the shadow lesson. It's not really a real lesson. You don't have to know anything about this to pass and get a 5 on the AP test.